Real quick before we get going, we are launching a new video series called March Mad CSS. It's a CSS battle tournament with 16 of the world's best developers. Josh Komu, Chris Coyer, Adam Wathan of Tailwind, Cassidy Williams, even Scott and I. Now, we have a ton of prizes to give away. And if you want to win, go to madcss.com and you're going to fill out the bracket. So madcss.com, log in with your GitHub, and you're going to pick who you think is going to win each of these. And whoever gets the highest score is going to win this amazing prize pack. Like this sick CSS jacket. You can also order this from the website as well. We got some pretty cool merch, some tees, stickers, and Nalgene. First, second, third prize. Go to Mad CSS, make your picks. You can share them with your friends. You'll probably win. Peace.
Welcome to Syntax. Today we have a really awesome guest on. Paolo Ricciuti is going to be talking about Svelte custom renderers and how the Svelte team is basically going to be taking a library that is entirely focused on the DOM and really putting it into a universe where, well, you can like render anything with it. So there's a lot that comes from that, both in strategy, but also in what that enables for developers who might be considering using this tool. And yeah, I'm really excited about this. So welcome to Syntax, Paolo.
Hi, welcome. Not welcome. Thank you for the welcome.
Of course. Yeah. Do we first meet in Barcelona? That's where we met somewhat recently, right?
Yeah. We met in Barcelona personally.
Yeah, the Svelte Summit, it was a great hang there. You're at a company called Mainmatter. What is it that you're doing, and what's your relationship to the Svelte project overall?
I lead the Svelte team at Mainmatter. Mainmatter is a consultancy. We do a lot of Svelte. We do Rust. We do Ember. Like it's basically a sort of a top tier consultancy. Like we're not just executors. Like we actually help you architect your solution. We help you hire even. Like it's more like on a high level. But we also do feature development and stuff like that. And basically, I am the Svelte expert there. And the reason why I am the Svelte expert there is because I'm very tied to the Svelte project. I'm one of the maintainer of the Svelte project. I started as a Svelte ambassador as Scott, which is basically like people that won't shut up about Svelte. And so...
yeah, that's me, right? That defines me, I think.
Yeah.
Sometimes we have to shut them up about it, but it's all good stuff here.
How did you find yourself in Svelte specifically? Did you do other frameworks before then? And you actually just recently published a blog post about why you chose Svelte. I don't know if you want to get into some of that.
Today, we published a blog post about why I chose and I continue to choose Svelte. And you can check it out on mainmatter.com if you want, on the blog post. But yeah, in general, I started with React, really. And like, nice thing, by the way, like my first approach ever to React was watching CJ doing with React. Yeah. And I still remember, like, I was taking my COVID vaccine for in 2020. And generally, I am a huge nerd in real life. So like I tend to like watch Syntax or watch conferences, even in my like off time. And so while I was waiting to take a vaccine shot, I watched Rethinking Reactivity by Rich. I literally fell in love with Svelte because like the idea of using a compiler to like ease the burden on the browser is something that like the moment like he mentioned it, I said like, why nobody else thought about this? Because it felt so obvious to me. And like from there on, I started using Svelte for some side project just for fun. I started learning Svelte just for fun. And then I started using it. I also participated together with Antonio Sarcevic. We teamed up and we built Svelte Lab, which is like a StackBlitz like specifically for Svelte kit. And we won the hackathon with that. And then this basically got me even more into the Svelte world. I became a Svelte ambassador. And from there, like it's just, it just freefold. Like For example, I am also the maintainer of the Blue Sky feed for Svelte. So I generally tend to joke that if it has the word Svelte in it, I'm probably somewhat involved in that.
Yeah, you've been like a really positive force in the Svelte ecosystem. I think it would be curious, or it'd be interesting for the audience to know, like, how do you go from being somebody who's just like you said, an ambassador, to somebody who's now actually working on the project?
Yeah. So like the reason why I started contributing, I always want, like, in general, I love open source. So I always did a lot of open source, be it like, I don't know, I want to create a new library because I have that need and I want other people to share the same, like, I don't want other people to feel the same need. So I create a library for it. So I always been very open source. And so when they were working on the rewrite to Svelte 5, they shared the like initial draft of Svelte 5 with the ambassador team, because the ambassadors are basically like, it's the first step of validation for some API. So like the first thing that we generally do is that like we build some API and then we like let ambassador critique that API so that we get some initial feedback. And so when I was an ambassador, I got some like access to the initial draft of the Svelte 5 repo. And like a few years ago, just for fun, I started building a reactivity system with signals. And so I knew a bit about signals, and I said, this is a good moment to start contributing to Svelte. And so like be it like a more like circle, like a small circle of people watching the contributions and stuff like that, I said, okay, I'll start to contribute to that. I also was very interested in learning like how the whole like abstract syntax tree, the word like the compiler word worked. And so I started to contribute to that. Then the repo went public and I continued to contribute. And the main motivation was I really want to like ease the experience for the maintainers, to let them focus on the things that really mattered. And so I started to pick up some small issues, and then I started to pick up some more difficult issues, and then more and more and more. And then in the end, like they really didn't want me in the maintainers, but I was too much of a presence.
Wes, how do you feel about that? Like, how do you feel about, like, I get so intimidated when I would, like, I've used Svelte like daily since version 3. I am a huge fan of the project. I follow along like the issues and all this stuff, and I would still have major imposter syndrome, feeling like trying to commit to it for some reason. I got a huge blockage there. Do you feel like that too? Like, would you commit to React or any of these big projects?
I don't know that I would commit to React, because so much of what they do is like planned out and it's being worked on somebody full time. But like larger projects that simply just need the help, absolutely, yeah. I think in most cases, if it's needed, why not? You know, kind of go for it. Especially if they have, like, you can kind of get the vibe from a repo whether or not they're actively searching for people to help them out. So yeah, go for it. That's how like everybody's story goes, right? Like Paulo's story is like that. Just go for it.
Yeah, but also like it's way less, like if you start, it's way less intimidating than that it might seem. Like the moment you start getting familiar with the code base, and you actually start getting familiar with the code base even before committing code. Like if you live in the issue tracker, like you will see other maintainers talking about, oh, we can do this and we can do this other thing and we can do this. And once you start seeing this, you start to get yourself familiar with the code base. And then at that point, it's really just a matter of, and I would say nowadays with AI, it's even simpler, because like you literally get like a very capable engineers that you can just even ask questions. Like you can just say, hey, how does Svelte handles like the parsing in this file? And it will break down stuff for you, and you can just say, okay, that's now I want to try to do it. And so
yeah, you can get up to speed real quick.
Yeah, really helpful for me when I was working on the zero Svelte bindings, because the state there was like way more complex usage of the Svelte reactivity APIs than I was used to in normal UI code. So like I really needed to dive quite a bit deeper into that stuff, building the zero bindings. So first of all, let's talk custom renderers. For people who don't use Svelte, they might not know how it differs from React. Yeah. Could you give like an overview about like how does Svelte use the DOM as opposed to like the virtual DOM, and then two, we can get into like what makes that challenging for custom renderers and go from there.
So I guess the main point is that React really is just a diffing library. So like I think like this is pretty common knowledge at this point, but basically like React itself does not concern with anything related to the DOM. So like they have the virtual DOM and it's just saying like, hey, create this element and like switch these attribute on and off, or change the value of the children of this thing. And then React DOM is the thing that actually says, okay, this is how you switch an attribute off on the DOM. And this is basically what allowed React to do stuff like Inc. or stuff like React Native, because the diffing algorithm, which is what React is doing the diffing algorithm, and then it's communicating with the virtual DOM. Like the virtual DOM is communicating with Inc. or with React DOM or with React Native. And each one of these renderers, I think React, they are called reconciliator. It's like has the knowledge about how to actually apply an attribute, how to actually remove a children, how to actually append the children in their own word.
So let me say for the audience really quickly, they might be wondering like, what is Inc? Inc is like React for terminal UIs. React Native is obviously React for native mobile UIs. You might not know this, but Raycast, the app that we use, is built in React, and they're not running browser or anything like that. It's they've built their own reconciler that render. If you build a Raycast app, you're just using React components, you're using Raycast tags, and then what happens is that like you can build a React app, but it actually renders out to native whatever, right? And it's you can't just go ahead and use CSS or HTML or anything like that in there. You have to use like the blessed tags that they've given you. But there's just so many different instances where React is used as a renderer to something else.
So like the difference is that Svelte, like famously, like when like Rich presented Svelte does not use virtual DOM. Now Svelte 4 and Svelte 3 was literally basically baking in the reactivity within like the compiled output. But even nowadays, that Svelte 5 is using like runtime reactivity with signals and stuff like that. If you take a look at the compiled output, and you can do it either in the playground or there's even a command in VS Code. Like if you are in a Svelte component, you can use a command from the extension, which is show compiled code, and it will show you the compiled code, like what that Svelte component, which is at the end of the day just a string, gets compiled to, because obviously you are not shipping the component to the browser. So like the way Svelte works is that it takes the string, which is your component, it will convert that into a JavaScript function, basically. And if you take a look at the JavaScript function, it's basically interacting with the DOM in real time. So like you will see stuff like get me like $.firstchild, $.setText, which is basically Svelte saying, okay, I want to set the text of this element to this kind of stuff. It was always imagined as a reactivity frame, like a framework for the web. And so like it was never actually imagined as a replacement of like it didn't have the concept of a custom renderers, because it was always, okay, we want to do web UI.
I will say, for folks, if you haven't messed around, I'll have a link to the Svelte Dev Playground. There is just a tab for JS output, and it's so readable if you want to really understand what's going on.
This actually changed a lot with Svelte 5. Like Svelte 4 was a lot less readable. And actually one of the design goal of Svelte 5 was actually to make it much more readable. And another small, nice thing that you can actually get from the playground, which is a very nice way to learn, is that since we have source maps, if you hover over something in the playground while the JS output tab is open, you can actually see which part of your Svelte component gets compiled to which part of your JavaScript file. So that's a nice touch if you want to learn how Svelte moves stuff around. Like, okay, this button that I have in my Svelte component, what it become inside my JavaScript file. As I was saying, like the Svelte custom renderers, we had the idea of, so at Mainmatter, we love to give back to the ecosystem that we thrive on. So since we use Svelte with our clients, we also love to do open source. We even have one day at a week, we can work on some open source project because we love to give back to the community. And so we've built some libraries. We've built Shipdog, for example, which is state management library that it's basically a way to juggle a sync task. Once we finish that project, which we are still maintaining it, but the big part was done. We said, okay, what can we do now for the Svelte ecosystem? And it happened that during that period, when we were looking for stuff to do for the Svelte ecosystem, a new framework came out, which proposed itself as the React Native alternative, which was framework agnostic. And I think you also did an episode on that, which is Lynx. And one of the requirements for Lynx, for it to be very Lynx, it is framework agnostic in the sense that technically you can literally write an application even in a normal JavaScript file, with the element API, which is their API to create an element inside a Lynx application. And it is technically agnostic, but to use it with Svelte, we needed a custom renderers. So we needed a way to render a Svelte component to something that was not the web. It was not a series of web.
There's no DOM available here, which that to me feels like a crazy undertaking, just given how deeply rooted the DOM is into Svelte, right?
Yes, it's not an easy task, and that's why it's taking a while, unfortunately. But it's something that it's doable, and I actually built a POC for it because, again, basically, we started working on this, and Mainmatter actually sponsored me to work on this thing for full time for 3 months or so. So my day-to-day job was to work on Svelte to build the custom renderers API. And during this period of time, first thing first, we had to make a change because always talking about the JS output in the playground, if you go to the playground and write whatever component, you will see something in the compiled output, which basically, if you have in a very simple component, the input and a button that is the normal, if you go to the playground, there is a default input plus button. If you switch to the JS output tab, you will see on line 5, var root $sign dot from HTML. And this from HTML basically is all the HTML tags in your component minus all the event listeners and stuff like that, and the dynamic part. So all the static part of your Svelte component as a string. So if you think about it, it is kind of wild. How can we convert from a string to actual elements? Because at the end of the day, you have to convert that string into an element, right? To actually mount it to the DOM, to add event listener to that string. And the way we are doing it, it's with a very neat trick, by the way, because I don't know if you are aware, but there is an HTML element, which is the template HTML element. And the template HTML element, if you write a template in HTML, it will not show up on the page. So it will create the element, but then those elements are not actually appended to the page. And then you can query the template and clone the template part. And so basically it's a way that you can declaratively render some some HTML and then reference it in JavaScript, and you can just populate that template however you want. Like, this is a trick that you can use if you want to use like normal JavaScript to build your components. So you can have a bunch of template in your HTML and then reference it and just fill it up with another variable. And that's basically what we are doing. So like we take the string, we create a template element on the fly, we set inner HTML, and then we extract that string, like that component, that component part on the fly.
Interesting. I didn't know that.
I don't totally understand how it works. Like how are you getting from Svelte code to like Svelte outputs like a paragraph tag? How does that then convert to whatever the native equivalent is on Android or iOS or whatever other target?
Here I'm just talking about like Svelte for the browser right now.
Oh, okay.
We will get to that. I will get to that.
Okay.
What I was talking is that like in the browser, we do that. Like we take your string and we pass it to the template element. The template element creates that element for us, which is very fast, by the way, because it's all done in the browser side, on the browser side. So like you don't have to do manually create element, create tag, create text and stuff like that. And then we just read those values. We say like, give me the first child of this template. Give me the first child of the first child of this template and stuff like that. Now, this obviously, like the reason why I started talking about this is because this is a huge problem, because if you want to render to something that is not HTML, how do you get the template tag, right? So like you would need to ask like whoever builds the Lynx renderer to create a template tag which takes a string and returns a series of elements, right? So that will be basically unbearable. Like it's just impossible for people to build custom renderers this way. And so the first work that we had to do, and this is actually a PR that I worked on during my sponsorship for like the period that Mainmatter paid for me to work on Svelte on this. And it's the fact that now you can actually generate. So if we go back to the JS output tab in the playground, now there is a new option for the compiler. So we can say svelte.compile, and then you can pass fragments 3. And if you switch to fragments 3, this is basically under the hood. Instead of using templates.innerHTML, is literally creating, like it's receiving an array which has the shape like the H1 with these children and these props, and then it's literally invoking document.createElement, document.setAttribute, document.blah, blah, blah. And so this was basically a required step before we could even start to think about rendering to something that was not the web, because without this step, you would need to create a template tag which was able to do all of this for you. So like this was the very first step, decoupling the logic from just get a string as input to get an actual array with all the elements and all the attributes and all the stuff. So this was something that was also needed in Svelte because there are some CSP policies that prevent you from using inner HTML in any form or way. So there were people that actually were suffering from this because they had these CSP policies, and as long as Svelte was using inner HTML under the hood, it was not working for them. And so this was a nice addition, like that we took, I don't know if it's something that people say even outside Italy, but we took 2 pigeons with a stone. That's
oh, yes. Yeah, we said
2 birds, 1 stone.
2 birds, 1
just
stone.
2 birds,
yes.
1 stone.
I like pigeons better, though. That's fun. More visual. And if you want to see all of the errors in your application, you'll want to check out Sentry at sentry.io/syntax. You don't want a production application out there that, well, you have no visibility into in case something is blowing up and you might not even know it. So head on over to sentry.io/syntax. Again, we've been using this tool for a long time and it totally rules. All right.
And so, yeah, basically this was the very first step to get something going on. And then from there, we basically went like we had two different directions that we like, two different ideas. The first one was kind of a crazy one, and I actually started implementing it. But we said, well, what if we like the custom renderer? So first thing first, let's talk about how will creating a custom renderer will work in Svelte. So basically, the way we need it to work is that you need to define some sort of module. So this can literally be a module in your project, or it can be an NPM package, for example, and you will like expose a module from these where the renders live. So like the renderer lives in this module, we import your module, and then we can use the methods that you define. So like you export default create renderer, and then you have to basically tell Svelte how to create an element in your world, how to update an attribute in your world, how to delete a children in your world, etc., etc. So because obviously, if we want to make this very, how can I say, very like flexible in the sense that it's not tied to anything, we basically need to go one layer above and say, okay, we don't even know what your word is. So your word could be the terminal, could be a Lynx application, could be a Svelte application, why not? And so you can, in this way, you that creates the custom renderer can manage whatever, like, how to render something in your word, basically.
That would effectively turn Svelte into something that could build terminal UIs and native apps. And like you said, what Svelte, for people who don't know, is the 3JS renderer for Svelte.
The first instinct was, what if when you create a custom renderer, like when you define those functions, we create a mocked version of the DOM so that then we can just pass it to Svelte, and Svelte will continue to invoke documents.createElement, but instead of document, it will invoke the renderer if the renderer is defined. And so like the first idea was we can make so that when you like create an element, you just return some extra information, and then we wrap your information with a DOM compatible API. So like we create a class, which is an HTML element like class. And so that when Svelte on that element call first child, we then invoke from within that class, we invoke your custom renderers to get the first child. And this was, I actually started implementing something like this, but then I quickly realized that the DOM is just a mess and you can't do that because there are so many quirks in the DOM which like are not really immediate. Like it's something that it's the silliest thing, for example, is that if you have an HTML element and you call text content is equal to empty string, that will actually remove all the elements inside that element from the DOM, right? It's simple, but it means that we have to manually check, like when we would have to shim text content, and then inside text content do something like if content is empty.
Yeah. And that's probably just like one of a thousand of these things.
Yeah,
right?
exactly. It was just too messy. And so the other thing that we did, and that's basically what I've built my POC on top of, is what we want to do is that we want to create another runtime, because again, if we circle back to the JS output of the playground, you will see that like the third line is import star as $sign from Svelte internal client. Mm-hmm. And that is basically our API. So like that Svelte internal client is all the JavaScript API that we use to interact with the DOM, to create a stateful variable and stuff like that. And so our idea was, let's switch that import. And so instead of importing from Svelte internal client, we import from Svelte internal custom. And then we can build basically the same runtime, but a very simplified version of the same runtime, because the client runtime actually has to do a lot of stuff, for example, for hydration. And hydration is just not a thing in the custom renderer world, because
right. Yeah.
obviously, like hydration makes sense if you are server-side rendering an HTML page. It doesn't make sense if you are building a native app, for example, or if you are building to the canvas, for example. Like there's no such thing as hydration. So we could remove all that part. But also the internal runtime is using a lot of these HTML DOM quirks to make Svelte as fast as possible. So as I was saying, like setting text content is equal to empty string to an element, it's the fastest way to remove all the elements from that element. So if we had to remove all these quirks, we would basically like put whoever uses Svelte normally at a small disadvantage just because we want to use the same runtime. And also it was from a maintainability perspective, because our thought was like, if we have two separate runtime, whenever we are working on the first runtime, we know that we are in the client runtime, and so we can use this DOM trick. And whenever we are in the custom runtime, we know that we are in the custom runtime and we can not use those DOM tricks. And I actually got decently far with this. So like I built a very small subset of the runtime. And then, because I wanted to try, like, blame me, but like I built a very minimal runtime, like where you could just use like props and state and like some basic element. And then I built a very basic version of a custom renderer for Lynx. So right now there is a Lynx app, which is a to-do app that I've built with Svelte. And I was so excited when I actually got it to work. It was my favorite to-do app ever. And the nice thing, like to circle back to your question before, Wes, which is like, how do you even relate like an input or a p tag to a native Android surface, for example? The answer to the question is really that when we will build this custom renderer API, Svelte will not care at all about that. Like you write a p tag, we just call the custom renderer and we say, hey, we want to render a p tag. And then it's up to whoever writes the custom renderer to say, okay, a p tag is something that needs to display text. So what I want to create is a text element inside Lynx. So you could do that.
So you could say like a custom renderer is like a translation layer then.
Yeah, basically.
Yeah.
Like it's basically
does Lynx supply that? Like does Lynx have tags that are like a text tag, or okay, so you
more or less, in the sense that if you read the Lynx documentation, basically what they supply is the PPI. Like they called it the PPI, which I assume that that's how it's spelled, but basically is an API that is close enough, like it's similar to the DOM API in the sense that you can have like underscore create element, and then you can create an element. Underscore set attribute, and then you can set an attribute. Underscore like flush tree, and it will re-render a specific portion of the page. There are specific attributes, and I guess like if you ever use React Native, it will feel familiar with you, because the Lynx element are called view and are called text. So like they are not called P, they are not called div or span. Like they are literally called text and div. But the nice thing about writing a custom renderer is that you kind of get to decide which elements you want. So like, because at the end of the day, Svelte will just invoke your function and say, hey, please create me a p tag. And then if you want to make the translation between a p tag and a text tag inside Lynx, it's kind of up to you. And it's very nice because like you can literally create whatever element you want. So like another thing that I did for a talk and also for fun, I created a terminal renderer, a very crud version of a terminal renderer, I would say, because one of the reasons why Ink is popular, but also because it's kind of slow. And we've seen this like going around because Cloud Code is built with Ink. One of the reasons why it's kind of slow is because it's using Yoga under the hood, which is like a library built by Facebook, I think, that basically tries to mimic Flexbox. Like you can just give it a bunch of like data, a bunch of objects, and it will calculate where those objects will fit inside a thing. So like this is a process that is kind of slow. And so Ink, it's much more featureful because they are doing this. So you can actually move stuff around and do like Flexbox and stuff like that. My terminal renderer was much more stupid. I was just using some basic ANSI code to like color stuff and do stuff. But it was very fun because like I had a Svelte component that was literally named like counter.svelte, and I had like text, which is counter, with the color attribute, which was one of my color. And pressing play, it was basically using an effect to increase the count and then using a derived to derive the color. And it was actually working. You could see like what you wrote inside the terminal changing color reactively. So like it was very fun.
Okay. And what about CSS? So React Native and Lynx support a subset of CSS, right? Like that's what Yoga is. It's translating regular CSS into whatever the like iOS or Android equivalent is. But one of the biggest pain points there is they don't support grid, which Lynx does support.
Yeah.
So what does that look like with Svelte CSS?
Yeah. So in terms of like Svelte obviously has scoped CSS, and the nice thing about that, about Lynx specifically, is that, as you said, Lynx really like, while React Native is kind of a worked down version of CSS, like they are doing like they support a bit of Flex, they support some CSS stuff, but they don't support everything, to the point that if you want to use Tailwind, for example, with React Native, you can't use Tailwind. Like you need to use a native wind, I think it's called, which is basically a new version of a Tailwind written specifically for React Native, as people usually do with React. Right, right, except like for the thing, like Lynx instead, like they have a very good support for CSS. So you can just use CSS and it will work, basically. And so in my POC for Lynx, like that part is actually untouched. So like you write your CSS and what the compiler produce is just the same CSS. And then it's up to you to actually like it's more of a bundler work. So like the work that I did for the Lynx POC was that I've used the Lynx bundler to say, okay, this is my CSS, the CSS type this component, please make it work. And it worked. The moment you started doing that, it just automatically worked. So probably if you want to do this translation layer where a p tag is a text, you will also need to do a bit of work to change the CSS into the other forms. Like you will need to do a bit of work. But at least for the moment, this is probably something that we can explore a bit. I don't know if there any work that we need to do to support custom renderers, like in the style tag, basically. There will be some part of Svelte that can't be ported to custom render, like that will be disabled for custom renderers, because obviously, like, for example, bind value really only works if we, Svelte, can register an input event listener on the input. So like there's a very specific amount of bind that you can do. So binding will probably be disabled like in custom renderer words. Obviously you can still use a listener. So like there is like one of the function that you need to provide when you create your custom renderer.
You do it the React way. Wait, so what does this realistically look like in terms of like actually existing for people to use? Timeline, what's the, where are we at?
So again, basically right now we had a lot of discussions with the rest of the team. One of the last discussion that we had, actually, we realized that our idea of splitting the two runtimes was more maintainable in the sense that when you write something in one runtime, you have a very clear idea of where you are, but it was very not maintainable in the other sense, because like you have a lot of code duplication that changes slightly, like just in like 2 or 3 characters is different. So like it would be a nightmare to maintain. So what I'm doing right now is actually rebuilding my POC so that we can use one single runtime, and then we use whenever we have this trick like that we use the DOM API in a certain way, we actually branch out. So like we say, if there is a custom renderer, we can invoke the custom renderer. Otherwise, we can use the shortcut. So like, we make the code slightly more complex in like having one single runtime, but it should help in the maintainability long term, because we will have, like if we fix one bug in an unrelated part, we don't have to fix that bug also in the custom runtime. Otherwise, we would have a lot of PRs that are basically just copy and paste of a fix in 2 separate files. So like that would be annoying. So what I'm doing right now is basically trying to rebuild this kind of part. In terms of like when will it be available, I don't know, because basically like after like Mainmatter founded me for 3 months, we are now actually looking for sponsorship for this. Like if there's some companies out there that wants to like build a native app with Svelte, or even something else. Like for example, we had discussion for people that wanted to build, I don't know, with WebGL. They wanted a renderer for WebGL. And so we are talking to sponsor that. And if you are interested in sponsoring, by the way, you can go to svelte-custom-renderers.com and you get in contact with us. What I hope is that if we find a bit more funding, when I was working on this before, AI was really not there at all. So I really hope that with the aid of some agent, I might be able to go a bit faster on this thing. And unfortunately, this is a big enough problem. Like I kind of feel, sometimes I kind of feel like annoyed with myself, because like I know that like technically I could work on this in my free time, like I do for the rest of the open source.
Spend all of your time,
like the rest of the open source. But the problem is that like this is a big enough thing that I really can't work. Like if I was to work on this on my free time, I would have 0 free time, and I would not be able to contribute anything else to Svelte for a very long time. And also working at increments of like 1 hour, because I have a 4-year-old kid. So it's not like I don't have like all the time of the world.
Yeah, I don't think you got to justify needing sponsorship to work on this. Honestly, this is a huge project. So we'll make sure we link that up. Syntax is going to be sponsoring some of this effort here, because we use Svelte full time in syntax.fm. We have a new Svelte Kit app. I obviously use it for everything, but man, it would be really cool to have custom render support. And to be clear here, folks, because we've been talking a lot about native apps and Lynx and stuff like that, we often get like people saying like, well, why not just use, what is it, or even like Cordova, whatever they call those things now, which is basically just a web view rendering web content in the DOM. That's not really what this is. This is React Native. This is a real native app that is being translated from Svelte code into whether that is Swift or what is it, Kotlin? Does Android uses Kotlin nowadays?
I think yes.
Yeah. But this would be done through the Lynx project, which is what TikTok is built on, and it's a really, really cool thing. So if your company's out there, you might find interest in this, sponsoring this as well. We'll make sure we have those links available. Really, really exciting work, and I'm really, really stoked to see what comes of it.
And by the way, there is like a guy, I just saw it yesterday in the Svelte Discord, that actually took my POC for Lynx, and somehow, because like it's a huge undertaking, because it's using a very old version of Svelte, custom made for that and stuff like that. And he actually made it work with Hermes, which is the engine behind React Native. So like, it's so wild.
That is crazy. All right, I got to check that out. All right, well, thank you so much for sharing all this. Man, I'm excited for all the work and really thankful for all the work that you and all the Svelte maintainers do. As a huge fan of this project. Now is going to be the part of the show where we get into sick picks and shameless plugs. A sick pick could be anything that you're just enjoying right now, and a plug is anything you want to plug. It could even be the Svelte custom renderers thing, that our website that we'll link up to.
Yeah, I would say like a sick pick is definitely, like, for me, something that I've been using a lot lately, and I really enjoyed using is OpenCode. It is my main driver for when I use AI, and it's lovely, and I really like it, and it's very flexible.
Yeah, I do too. I use it as my main, and it's just like, I don't want to be using the product that's tied to one model, and I want it to be fully configurable. When I got brought out to talk to the VS Code folks about the like Copilot CLI, and all my requests were like, I need to be able to customize these paths. I need to be able to customize this. Like, it's all the stuff that I have set up in OpenCode. I love to tweak my tools, so I get that. And shameless plugs. What would you like to plug?
Well, obviously, like, I will plug once again svelte-custom-renderers.com. If you want to join the initiative, you also get a shout out from our socials, and you will help bring this to the finish line. If I'm allowed, I would also like to shield another project of mine, which is TMCP, which is it's something that I've been trying to shield as much as possible, because I've built basically a competitor SDK to build MCP server with TypeScript. It is, like, in my opinion, a bit more lightweight. It has less bloat of dependencies. To be fair, like, the official SDK, it is getting way, way better. But I've built this, like, alternative SDK which uses web request and web response instead of node request and node response. It's using standard library, so you are not tied to Zod. Like, you can use whatever validation library you want.
Oh yeah.
It's much more modular. So, like, I have, like, the transport part separated so that if you want to build your HTTP transport, you don't have to get all the dependencies of the stdio transport. And much importantly, like, vice versa. Like, if you are building an stdio MCP, you will not get Express as a dependency and stuff like that. Again, like, this is, like, the official SDK is getting way, way better. And but yeah, the Svelte MCP is built with TMCP. The Storybook MCP is built with TMCP.
What about the syntax MCP?
The syntax MCP is built with TMCP because I actually opened a PR to build the syntax MCP.
I'm sorry for not getting that merged. We're working on a big rewrite, so there's like some precedence there. Wait, you said you can use any type of you said Zod, or what's your preferred schema
Valibot,
library
100%.
for that? Which one?
Valibot.
You like Valibot the best. Why do you like Valibot the best?
In terms of validation libraries, if I have a validation library, I don't want to feel bad if I ship that to the client. Like, maybe I don't need it, but if I need to ship it to the client, it's nice to know that my users will get like 1 kilobyte instead of 10.
Cool. I love that. Hell yeah.
Beautiful.
Cool. You got anything, Wes?
I don't know. I think this is good. I've got a list of things to check out. We talked to Zach when he came on. He works at ByteDance about Lynx, and this was before it was released, and now it's out, and it's really cool to see people are writing custom renderers and fussing with that. So certainly excited to check that out now.
Yeah, absolutely. Cool. Well, thank you so much for coming on the show. It's been a long time coming, and I'm sure we'll chat soon.
Yeah. Thank you for having me.
Peace.
Bye.
Peace.